belt between Mars and Jupiter, while comets come from further out, as we have heard. And right now, if you look at these objects that really come close to Earth, it's more than 10,000 asteroids known that can potentially come close to Earth, and only 94 comets. And those objects have hit Earth in the past. We have impact craters found on Earth, and just last year there was an object now believed to be only 19 meters in diameter
in Russia,
which exploded in the air over Russia, and you can see a picture here of a fireball, and it caused injury on the ground. It was only 19 meters, so you can imagine if a much bigger object would hit Earth, what damage it could do. And we try to find those objects, to assess the risk and to measure them. So we have to learn a lot, and then we also start to think what one could potentially do against them.
But the good news is indeed that we know about thousands of objects larger than 1 kilometer. The bad news is that about factor of 10 are unknown.
Okay. If asteroids are so much more dangerous to us on Earth, why do we study comets instead?
Because comets are much more important from scientific point of view. No. And much more fascinating. But comets are much more primitive than asteroids. I think that is the key point. Comets really have the material. If we get to material that was here in the pre-solar nebula, then we have to study comets. That's what we still think. And I believe after Rosetta, this will be even more confirmed.
Okay.
And also comets, give us a clue to the infant state, to the infancy of our solar system, and we want to see what material was there. Were there complex molecules? Was there water that perhaps was brought by comets to the Earth? Is still one of the possibilities, but I think the real big point is to see how complex the material is in comets, and and to understand how the planets evolved out of this. And therefore, for me, scientifically, they are more important. They are not as dangerous as the others.
It just beats the others.
If I might add to this, I would say asteroids are more dangerous because there are many more of them, but most of them are smaller. But comets, if you just take one object, they are bigger, typically several kilometers in size. They are faster moving than asteroids if they would hit Earth. And as we heard before, they are completely unpredictable, at least in their orbit. For their orbit, that counts as well. So for one individual object, I would say comets are even more dangerous. And I agree, they are scientifically more exciting.
But the good thing is, I've learned that the Airbus Defence and Space currently carries out a study called Don Quixote, together with the US and Russia, presumably in order to learn a bit more about near-Earth objects, some of which could be comets as well. However, I did stumble over the name Don Quixote, to be perfectly honest. Why that name? Don Quixote fought windmills. What does it tell us about that study?
Okay, in order to be clear, we performed a study called Don Quixote on a phase A level for ESA years ago. And that was Don Quixote having 2 spacecraft, one orbiter and one impactor, and the impactor was supposed to deflect the object which was ahead to Earth. And at this time, we have, so to speak, some sort of extension of that study, namely on behalf of the EU, we investigate methods to mitigate such near-Earth objects with different methods, not only by impacting and deflecting objects, deflecting objects by impact, but also by gravitational attractor or by some explosives close to a dangerous object. And that study is running this time, and it's a worldwide study team involved.
Okay. Now, let's leave all the danger behind and let's leave Earth behind for a moment. Concentrate on Rosetta again and its comet. I mentioned earlier that Rosetta is obviously now traveling for some 10 years, been asleep for 3 years. We all change with time, and even objects change. They don't remain the same. So is the Rosetta that left 10 years ago still the same, Rosetta, or do we have to expect some alterations there? I mean, it's been exposed to an asteroid belt, maybe external radiation. We don't quite know. How well is Rosetta prepared to deal with all that?
I think Rosetta is still and should be the same, otherwise there would be a risk that it doesn't work as it should. But we have, when Rosetta was designed, all these effects were taken into account. You know, the electronics is, so to say, radiation resistant or radiation hard. The spacecraft was built to at least work for 12 years. All the technology used is based on experience, for example, with communication satellites that work for 12 or 15 years because they have to bring back money. And all this was thought about. We also, the solar arrays, and as we go closer to the sun, they were also designed that even if they degrade over the 10 years, which to some extent they do, they should still provide, also at this distance now where Rosetta is, enough power. Mm-hmm. And the instruments were built like this, that the electronics should work. So this was taken into account. So the spacecraft should be the same. The question we might ask with our instrument might have evolved, because 10 years and 10 years of comet science, a lot of things have happened. But still, what we can demonstrate is that Rosetta, the importance of Rosetta has not changed. Everybody admits that this is the next important step in cometary research. Mm. So this has been done. I think we have had a good vision. We knew what we would do, and I think that will hopefully show in a couple of months.
There was also an interesting thing when you said that things change. Also, the questions. I mean, when Rosetta was designed, when the instruments were designed, when it was launched, there was a certain set of questions that you hoped to get an answer for. Are the questions still the same, or have some of these questions maybe been answered in the meantime or altered?
I can say the questions are still the same, and I have to admit that. I said this morning, after 10 years, where I always said, you know, we are going to measure this, we are going to measure this. Now we will measure it, hopefully, and I don't have to repeat that. But the missions we had in the meantime, because the Americans had a couple of these flybys at other comets, if you look there in their objectives for their future missions, it's exactly the same objectives, the same question we have put forward. And the new missions, and especially Stardust, which brought back a sample of Comet Wild, opened a lot of Pandora box of new questions which are not consistent with our understanding. And that still, it shows we have to learn more.
Mm-hmm.
So I'm prepared for the unexpected, according to the quote from David Levy before. Yeah. And you know, the most interesting point with our space missions were questions which came back we never were able to ask.
Mm-hmm. So basically the mission comes up with the questions. Yeah,
yes,
I mean, that's brilliant.
Yes, yes. That's my conviction.
Yeah.
Yes.
Yeah.
Maybe I could add something not really on the risk aspect, but a bit related. What happens near Earth? I mean, every night on a clear sky, you can see some meteors, some falling stars. And these have been observed for thousands of years. But there is a lot of these are not really understood. What is the composition? Where exactly do they come from? It is believed that those mainly originate from comets. And sometimes every year Earth passes through. So it is something that where you have direct experience. They are not really dangerous, at least not on the Earth. Maybe to spacecraft in orbit they are, but even there you can learn something from missions like Rosetta. So something that happens on Earth every day.
Now this is, of course, the whole mission is a huge effort, and it took some 25 years of preparations and plus the scientific evaluation that'll follow once we get all the data. What exactly is the longevity of such a mission and also of the results that you hope to get from it?
The impact the mission will have will be, at least on science, it will be felt decades after. But it depends on my dear science colleagues that they work hard to analyze the results, do it jointly, and you know, this is a worldwide undertaking with all the cultures in there. And I'm pretty sure that just if you go to the mission to analyze the results, will bring us a couple of years after the end of the mission. This is to analyze the data. But at the same time, it's not only the measurements we're doing. We have, as we mentioned before, you have to put it in the great context. You want to see put comets in the context of the evolution of the solar system, comets perhaps in the context of the evolution of life. And that means that people have to work together. You take aspects from the different instruments, and we said that before, we bring a laboratory to a